Good day, everyone. Today we are going to learn about solving exponential equations. So without further ado, let's get to it. Now, what is an exponential equation? Basically, it is just any equation in which a variable occurs in n or its exponent. To give you a concept of what an exponential equation is, here are some of its examples. To explain further, let us know the basics of solving exponential equations. Now, when we solve for exponential equations, we must recall the law of exponents as well as the property that if x and y are real numbers, and if b to the power of x and b to the power of y are equal, then x must be equal to y. So we must note that we must recall the law of exponents in order to solve exponential equations. Now here we have the definition, the one-to-one property, and the theorems we use to successfully solve for exponential equations. Now we need to note these because we will use these theorems to easily simplify and solve for exponential equations. Steps in solving exponential equations. Number 1, write both sides of the equation as powers of the base. Number 2, use the law of exponents or simply equate the exponents. Number 3, solve for the variable. And number 4, check the result with the original equation. So without further ado, let's start solving. Now here we have example number 1. 5 to the power of 3x is equal to 5 to the power of 7x minus 2. Now to solve for this, we first check its base. Now as you can see, the base is equal, so we got it all covered. We then bring down the exponents. So we bring down 3x and 7x minus 2. We have this. To simplify, we combine like terms. So we combine 7x and 3x. We transpose 3x onto this side, which becomes negative 3x. Now we then transpose negative 2 onto this side, and then it becomes positive 2. So we then simplify. Upon simplifying, we have a result of 2 is equal to 4x. Now, we need to solve for the variable, which is x. To do so, we divide both sides by 4. After doing so, we get a result of x is equal to 2 over 4. But we can still simplify this and convert it to its lowest term, because 4 is divisible by 2. And if we do so, we have a result of x is equal to 1/2. Now for the checking, when x is equal to 1/2, we just simply replace x, this and this, with 1/2. So we have 5 to the power of 3 times 1/2 is equal to 5 to the power of 7 times 1/2 minus 2. Upon simplifying, we then get 5 to the power of 3 over 2 is equal to 5 to the power of 7 over 2 minus 2. Upon simplifying this part, we get the same result of 5 to the power of 3 over 2. Therefore, x equals 1/2 is the solution to the equation 5 raised to the power of 3x is equal to 5 raised to the power of 7x minus 2. Moving on, we have example number 2. 4 raised to the power of t raised to the power of 2 is equal to 4 raised to the power of 6 minus t. To simplify this, we first check its base. Again, it is the same, so we then bring down the exponents, t squared and 6 minus t. To simplify it, we then transpose this part onto the left side. So we will have t to the power of 2 plus t minus 6 equals 0. After doing so, you can see that it is factorable. We then factor this equation After doing so, we get a factor of t plus 3 times t minus 2 equals 0. We then equate both of these to 0. So t plus 3 equals 0 will be equal to t equals negative 3, while t minus 2 equals 0 will become t equals 2. Now for the checking. When t is equal to negative 3, again, we replace t with negative 3. So we get 4 raised to the power of negative 3 raised to the power of 2 is equal to 4 raised to the power of 6 minus parenthesis minus 3, close parenthesis. Now, upon simplification, we get 4 raised to the power of 9 equals 4 raised to the power of 6, and since we got this, it becomes a plus. So we have 6 plus 3. Upon further simplifying this one, we get 4 to the power of 9 equals 4 to the power of 9, which is the same. So this one is a solution to this equation. But there's still one more. When t is equal to 2, so we get 4 raised to the power of 2 raised to the power of 2 is equal to 4 raised to the power of 6 minus 2. Upon simplifying this, we clearly get a result of 4 raised to the power of 4 equals 4 raised to the power of 4. Therefore, t equals negative 3 and t equals 2 are solutions to the equation 4 raised to the power of t raised to the power of 2 is equal to 4 raised to the power of 6 minus t. Here we have example number 3. 3 raised to the power of z is equal to 9 raised to the power of z plus 5. Now, to solve this, you have noticed that the bases aren't the same, right? So we then convert this one into into having a base like this one, or we convert this one into having a base like this one. But for this one, we will convert 9. Now, we all know that 3 to the power of 2 is always equal to 9, thus we use it. Now, as you can see, we have the same base, where 2 is just multiplied by the original exponent of this term. Now, the next thing to do, since the base are the same, we then bring down the exponents. We bring down z, and we bring down 2 times z plus 5. After doing so, we simplify it. So we distribute 2 onto this term. We have a result of z is equal to 2z plus 10. Again, we combine like terms. So we transpose a z onto this side, which becomes negative, and we transpose positive 10 onto this side, which becomes negative 10. So upon simplifying, we have a result of negative 10 is equal to z, or z is equal to negative 10, like this. Now for the checking. When z is equal to negative 10, again, we replace z with negative 10. We have 3 raised to the power of negative 10 equals 9 raised to the power of negative 10 plus 5. We then simplify. We have 3 raised to the power of negative 10 equals 9 raised to the power of negative 5, which will both have a result of 1 over 59,049. Therefore, x equals negative 10 is the solution to the equation 3 to the power of z equals 9 raised to the power of z plus 5. Example number 4. 4 raised to the power of 5 minus 9x equals 1 over 8 raised to the power of x minus 2. Now, to solve these, you have noticed that the bases are different, right? We then find a number in which both of the bases will then be equal, or will then be the same. So, upon analyzing it, we get a base of 2. Because 2 raised to the power of 2 will be equal to 4, and 2 raised to the power of negative 3 will be equal to 1 over 8. Now, we have 2 raised to the power of 2 times this, the exponent, the original exponent given. Now, also, on the other side, we have 2 raised to the power of negative 3 with the exponent of x minus 2. Now, upon simplifying it, we have now noticed that the base are the same as stated before, right? We then bring down its exponents, so it becomes 2 times 5 minus 9x equals negative 3 times x minus 2. So we then distribute this to this, and then this onto this. Upon doing so, we got a result of 10 minus 18x equals negative 3x plus 6. Now, we combine like terms, and we transpose it. Upon doing so, we transpose 6 onto this side and 18 onto this side. So we have 10 minus 6 minus negative 3x plus 18x. So upon simplifying this one, we get a result of 4 is equal to 15x. Now we need to solve for the variable x, so then we divide 15 both sides with both sides. After doing so, we get a result of x is equal to 4 over 15, or 4 over 15 is equal to x. So upon checking, when x equals 4 over 15, we have a result of 4 raised to the power of 5 minus 9 times 4 over 15 equals 1 over 8 raised to the power of 4 over 15 minus 2. Upon simplifying, we have a result of 4 raised to the power of 5 minus 12 over 5 is equal to 1 over 8 raised to the power of negative 26 over 15. Then we simplify again. Then we will have 4 raised to the power of 13 over 5 is equal to 1 over 8 raised to the power of negative 26 over 15. Now, if we convert these onto decimals, we will have the same result of 36.76. Therefore, x equals 4 over 15 is the solution to the equation 4 raised to the power of 5 minus 9x equals 1 over 8 raised to the power of x minus 2. Number 5. 6 raised to the power of 2x is equal to 6 raised to the power of 1 minus 3x. Since the base is the same, we directly bring down the exponent. So 2x is equal to 1 minus 3x. We then combine like terms. So we transpose this and we transpose this. So it then becomes negative 1 equals negative 3x minus 2x. We then simplify. It then becomes negative 1 is equal to negative 5x. Now we solve for the variable x. So we divide both sides by negative 5, earning us an answer of 1 over 5 is equal to x. Now for the checking. When x is equal to 1 over 5, again, we just replace this and this with 1 over 5. We then get 6 raised to the power of 2 times 1/5 equals 6 raised to the power of 1 minus 3 times 1/5. Upon simplification, we get 6 raised to the power of 2 over 5 equals 6 raised to the power of 1 minus 3 over 5. We then get the same result of 6 raised to the power of 2 over 5. Therefore, x equals 1/5 is the solution to the equation 6 raised to the power of 2x equals 6 raised to the power of 1 minus 3x. Number 6. 5 raised to the power of 1 minus x equals 25. Now, as you have noticed, again, the base aren't the same, but we know that this can be converted into 5 raised to the power of 2 because 5 squared is equal to 25. So we then do so. Now, we have the same base, right? We then bring down its exponents, so it will become 1 minus x equals 2. We then simplify and transpose 2 onto the left side, so it becomes 1 minus 2 equals x. We transpose negative x onto the right side. So upon simplifying, we will have a result of negative 1 equals x. So checking. When x is equal to negative 1, again, we replace this with negative 1. We have a result of 5 raised to the power of 1 minus parenthesis minus 1 close parenthesis equals 25. We then further simplify it. It becomes 5 raised to the power of 1. Because of this, it becomes plus, and we bring down 1. Equals 25. Now we simplify, it becomes 5 squared equals 25, which is 25 equals 25. Therefore, x equals negative 1 is the solution to the equation 5 raised to the power of 1 minus x equals 25. Example number 7. 8 raised to the power of x squared equals 8 raised to the power of 3x plus 10. Now, since they have the same base, we then directly bring down its exponents. So x squared equals 3x plus 10. We then transpose 3x plus 10 to the left side, so it becomes negative 3x minus 10. So the term will become x squared minus 3x minus 10 equals 0. You then notice that this is factorable. So then we factor it, in which its factors is x minus 5 times x plus 2. We then equate the both of these onto 0, having a result of x equals 5 and x equals negative 2. Now for the checking, when x equals 5, 8 raised to the power of 5 squared equals 8 raised to the power of 3 times 5 plus 10. We'll have a result of 8 raised to the power of 25 and 8 raised to the power of 15 plus 10. So upon further simplifying this one, they both will be equal to 8 raised to the power of 25. Now for the second one, when x is equal to negative 2. 8 raised to the power of negative 2 squared equals 8 raised to the power of 3 times negative 2 plus 10. We'll have a result of 8 raised to the power of 4 is equal to 8 raised to the power of negative 6 plus 10. And if we simplify it, it both will be equal to 8 raised to the power of 4. Therefore, x equals 5 and x equals negative 2 are solutions to the equation 8 raised to the power of x squared equals 8 raised to the power of 3x plus 10.
Number 8.
7 raised to the power of 4 minus x equals 7 raised to the power of 4x. Now, since the base are the same, we directly bring down its exponents. So it becomes 4 minus x equals 4x. We then combine the like terms, transposing negative x to the right side. So it becomes 4 equals 4x plus x. We then add, so it becomes 4 is equal to 5x. We then solve for the variable x and divide both sides by 5. We then have a result of 4 over 5 equals x. So upon checking, when x equals 4 over 5, we have a result of 7 raised to the power of 4 minus 4 over 5 is equal to 7 raised to the power of 4 times 4 over 5. We'll always have a result, or we'll always have the same result of 7 raised to the power of 16 over 5. Therefore, x equals 4 over 5 is the solution to the equation 8 raised to the power of x squared equals 8 raised to the power of 3x plus 10. 2 raised to the power of 5x equals square root of 2. Now, to solve this, we first need to convert this, or need to put an exponent onto this term. So if we do so, you need to remember that square root has an exponent, or is an exponent of 1/2. Therefore, 2 will have an exponent of 1/2. Now, as you can see, we then have the same base. So, what we do next is to bring down its exponents. Thus, we bring down 5x and 1/2. So, 5x equals 1/2. Now, we need to solve for the variable x. So, we divide both sides by 5. After doing so, we get a result of x equals 1 over 10. Now, for the checking. When x equals 1 over 10, meaning when we replace this with 1 over 10, we have a result of 2 raised to the power of 5 times 1 over 10 equals the square root of 2. And if we simplify this, it will become 2 raised to the power of 1/2. And if we convert this, it will become square root of 2. Thus, it is equal. Therefore, x equals 1 over 10 is the solution to the equation 2 raised to the power of 5x equals square root of 2. 10. 3 raised to the power of 4x minus 7 equals 3 raised to the power of 2x over 3. Now, the first step we will do is to find a way so that its base will be equal. Thus, we have a result of 3 raised to the power of 4x minus 7 is equal to 3 raised to the power of 2x minus 1, because this is considered to have an exponent of 1. Thus, we just subtract it here, right? Now, since it has the same base, we then bring down its exponents. So 4x minus 7 equals 2x minus 1. We combine like terms and we transpose. So we have 4x minus 2x equals negative 1 plus 7. See? Now we simplify. So we have 2x equals 6. Now we need to solve for the x variable. So we then divide both sides with 2 which will give a result of x equals 3. Now for the checking. When x equals negative 3, it will have a result of 3 raised to the power of 4 times 3 minus 7 equals 3 raised to the power of 2 times 3 over 3. It will then result into becoming this one. Upon further simplification, we will have 3 raised to the power of 5 equals 3 raised to the power of 6 over 3, which is equal to 243. Therefore, x equals 3 is the solution to the equation 3 raised to the power of 4x minus 7 equals 3 raised to the power of 2x over 3.
Thank you for watching and stay safe.